Illustrative Math, Algebra 2, Unit 6, Lesson 3 is called the Unit Circle, Part 1. All right, so our goal today is I understand that a radian angle measurement is the ratio of the arc length to the radius of the circle. And the second one is I understand that points on a unit circle can be defined by their coordinates or by an angle of rotation. Okay, so first of all, you might be asking, what is a radian? Well, it's a different way to measure angles, and 1 radian is basically the angle that would give you an arc length of 1 radius. So, this length right here, this red and this blue right here, these are the same length. Okay, if I took a piece of string and measured the radius, and then I wrapped a piece of string around the outside of the circle, they would be the same length. So this angle is 1 radian. Okay, and this is not in your book. This is extra notes that I'm giving you there to help you understand it a little bit better. All right, so here's our warm-up. The x-coordinate of a point on the circle is 3/5. What does this tell you about where the point might lie on the unit circle? Find any possible y-coordinates of the point and plot them on the unit circle. So when we say unit circle, it's a little vague. It doesn't really tell you what that means. It means that radius equals 1 unit. So this radius is 1. If you count the blocks there, I think there's 10 of them. Okay, so every block is 0.1. So this would be, 1, 0 here. This would be 0, 1. This is -1, 0. And this is 0, -1. So 3/5 would mean I'd have to go, remember, 3/5 is the same as 6 out of 10. So 0.6 would be my x-coordinate. So 3/5 or 0.6, I'm going to go to the right 1, 2, 3, 4, 5, 6. So anywhere on the circle, so I could put this point or this point. Both of those have an x-coordinate of 3/5. So the y-coordinate that would go with it, well, I could count how far up do I go? It looks like I go 1, 2, 3, 4, 5, 6, 7, 8. So it'd be 8 out of 10, which is 4/5. And then this would be the same thing, but -4/5 because I went down. Okay, so there's my answers right there. It's 3/5, 4/5, and then we'd also have 3/5, -4/5. Now it's real nice when you got a graph there. If you don't have a graph, I'll show you how to do it with Pythagorean's theorem. So the y-coordinate is -0.4. So I go down 4 out of 10. 1, 2, 3, 4. So that point would be right there. And that point would be right there. Okay, so when I look at that, it looks like my x-coordinate is 0.9. And then the other one is -0.9. Okay, so I'll write it right here. Oh, I had them backwards. Whoops. So there you go. Now I'm not sure if it's 0.9 because it's kind of hard on the graph. So maybe if I made a triangle and did a little Pythagorean's theorem here, it might be a little bit more accurate here. So here's my triangle. So this is 1 for your radius. This is negative. Oh, that's supposed to be negative. Sorry, -0.4, and then this is going to be x. So if I did x squared plus -0.4 squared equals 1 squared, let's see what we get. Whoops. And when I go and do my square root of 0.84, I actually see that I think it's not going to be 0.9. It's actually a little bit bigger. The square root of 0.84, it's actually 0.9165. So that would actually be a little bit better. Okay. So the graph is nice to kind of visualize it, but math is a little bit better because can get a little bit more accurate answer. All right, so all points are 1 unit from the origin, meaning if I drew a straight line to the origin, your circle essentially has a radius of 1 unit. Choose one of the points, be prepared to describe its location using only words. Okay, let's do, I don't know, let's go this one right there. All right, where is that location? So I would say, I don't know, let's say, looks like I'm going to go left a little bit under 1. So less than -1, okay, and go down a little, let's say about 0.4, okay. So if I know it says using only words, but if I wanted to write a coordinate, again, this is an estimate, I'm just going to say, okay, I think that thing is at like -0.8 and -0.4, okay. It's just an estimate. I don't know exactly where it is. Looks like a little less than half, but now if I plug this into Pythagorean's theorem and it doesn't fully fit, if I don't get it equal to 1, then technically that point's not on the circle. So you'd have to kind of, to make sure that point was fully on the circle, you'd have to do -0.8 squared plus -0.4 squared and see if that equals 1, which this is not going to work. So, because I get 0.64 plus 0.16, this is going to be 0.8, is not equal to 1. So this point is definitely not on the circle, but, it's, again, just an estimate. So just, if I wanted to pick this point right here, I'm going to go to the right about 0.5. It looks like I'm going up about 0.75. But again, if this doesn't fit in properly to the Pythagorean theorem, it's probably not on the circle. How could I find the actual more accurate? If I estimated this at 0.5, what I could do is 0.5 squared plus y squared equals 1 squared. And then you could find it a little bit better. Y squared equals 0.75 square root. 0.87 might be a little bit better. Okay, so there you go. All right. So if you were in class, I would give you some sort of circular object, and we would maybe measure a radius with a string and kind of like fit it around the circle. But I don't really have the ability to do that on here. But how many radii does it take to go halfway around the circle? So, if I know my radius, let's just say my radius is 1, okay? The full circle circumference equals 2 pi r, okay? That's your formula for circumference of a circle. So a full circle, if my radius is 1 unit, would be 2 times pi times 1, which would give me 2 pi. So if I wanted to find half a circle, I would just divide by 2, so I would get pi, okay? So 3.14 approximately. So all the way around the circle, I kind of did that as I was finding that answer. It's 2 pi, or approximately 6.28. All right, so, you would measure it out in class, but, we're just going to do it with the old algebra there. All right, what is the exact number of radii that fit around? Well, I guess this was about. So I guess this was 2 pi. I kind of already did it. Why doesn't the number of radii that fit around the circumference of a circle depend on the radius of a circle? Why does it not depend on that? Well, I would say they're proportional, okay? The radius and circumference are proportional. Okay, so like for instance, if my radius was bigger, it would still wrap around the same amount of times because as my radius gets bigger, so does the circle. Okay, so if if this radius was 10, then the circumference would be 20 pi. It's still proportional to each other. All right, so here's a little visual here. There are 2 pi radians in a full circle or pi radians in a half circle. So, one radius wrapped around. This is 1 radian, 2 radians, right? A radian is the angle. It's the angle here that gives us an arc of 1 radius. So this radius and this arc are the same length. So you'd actually have 6.28. All right, this would be like 0.28 approximately. Okay, 0.28 of a radius right there. Okay. All right, so let's look at this one. A bicycle wheel has a 1 foot radius. The wheel rolls to the left, so counterclockwise. What is the circumference? Well, 2 pi r. So 2 pi times 1, so that'd be 2 pi feet. Mark the point Q where P be after the wheel has rolled 1 foot to the left. So 1 foot would be like I took pi, half a circle is pi. So 1 foot would be, it'd be like I took this radius here and rolled the same amount right there. So wherever, we said 1 radian is approximately there. We know that we're going to have a little over 3 radians in half a circle. So I'm going to put that there. And I'm going to just, I'm going to explain it by saying, the radius is 1 foot. So in half a circle, we would have 3.14 radii. So I'm kind of just estimating it there, but I'm kind of saying, okay, 1 arc, another arc, another arc, and then you got this 0.14 left. Okay, so it'd be 1, 1, 1. Half a circle would be 3.14. All right, mark the point R where P will be after the wheel is rolled 3 feet to the left. So that's going to be right about there. Explain your reasoning. I guess I kind of already did. Where will the point be after the bike has traveled pi feet to the left? So pi, hang on a second here. Pi would be right here. Pi feet to the left. What about 10 pi feet? So 10 pi feet would be like 1 pi, 2 pi, 3 pi, 4 pi, 5, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi. 10 pi would be right there. That'd be a point P. Okay. After traveling some distance to the left, the point P is at the lowest location in its rotation. How far might the bike have traveled? So to get the lowest point, that would be like, you started here, traveled around the circle and stopped right here. I'll call that L for low. So it'd be 3/4 of a circle. So let's just do this. 3/4 times a full circle is 2 pi to go all the way around. So I'm going to get 6 pi over 4, reduce it, it's 3 pi over 2. Okay? All right, so you can divide a semicircle or a circle into equal sections. So remember, a half circle, a semicircle is pi radians, okay? So a semicircle is pi radians. So I'd have 1, 2, 3, 4, 5, 6 of these. So, this is like saying I take my pi radians and I divide by 6. So each section here, 30 degrees, because it's 180 degrees, or pi radians. I guess I wrote them backwards because it's written in radians first and then degrees. Pi radians, or 180 degrees. So if I divide it by 6, it obviously would be pi over 6 equals 30. Same thing here. I have, a full, 3 sections here of the circle. If, pi radians, or 180 degrees, if I divide by 3, pi over 3 radians is 60 degrees. And graphically, it's 1/3 of a semicircle. If I divide it by 4, okay, it'd be, pi over 4 radians equals 45 degrees. All right, so how far does the point have to rotate before the x values of p start to repeat the same order? I guess I should probably give you a picture here. So I'm assuming that this question was kind of with our circle problem here. Whoops, not a rectangle, we want a circle. So I guess the question would depend on where P is. So if I drew it right here, P, right there. How far does the point have to rotate before the x values of P start to repeat in the same order? So to get back to this exact same spot, I would have to go all the way around. So let's call this original angle here theta. Okay, so if I want to get back to that exact same spot, I would have to rotate all the way around an extra full circle. So, it would have to go 360 degrees or 2 pi radians, because we already said a full circle is 2 pi radians. Now, if I wanted just the same x coordinate, I could go down here and I could, rotate a little bit less than a full circle. All right. So how many radians can P rotate to have a negative x value? So here's my point. To get a negative x value, I need to get just down here. So I would need to rotate, I don't know, a little bit over, a third of a rate. I don't know, maybe looks like a little bit more than a radius. So I'd say a little more than 1 radius, because this arc length looks a little bit longer than the radius, a little more than 1 radian. How many radians can P rotate and have a negative x value? So it could go all the way to here, and then the x value of that point would start being positive because it's on the right side. So you kind of just estimate how many radii you could wrap around the circle here. So, oops. So, you just kind of start looking here, how many radii? So 1, 2, probably a little over 3. So I would say a little over 3 radians or 3 radii wrap around the circle. If point P rotates through 5 pi over 4 radians, where is it? How do you know? Okay, so if it rotates through 5 pi, okay, so point P, 5 pi over 4. So a full half circle is pi radians. So to get exactly over here on the other side, this would be like I added pi radians, or in other words, 4 pi over 4 would be like if I slice my circle into 4 equal sections. Okay, so then I'd have to go another right there. Okay, so that would be 1, 2, 3, 4, 5. So I'll call that right here. 5 pi over 4 would be where it would rotate from point P. Okay. All right. So I understand that a radian angle measurement is the ratio of the arc length to the radius of a circle. I understand that points on a unit circle can be defined by their coordinates or by an angle of rotation. All right. Here is a circle with a radius of 1 unit. Arc PQ has a length of pi over 3. What is the measure of angle POQ in radians? Well, if the radius is 1 unit and it has a radius of pi over 3, it's just pi over 3 radians. If Q has an approximate coordinates of 0.5, 0.87, name one other xy coordinate pair that must also be on this circle that has either the same x or y coordinates. So I can move at any one of these 4 spots as long as they're equal. Okay, like this is the same height. This is the same x coordinate. This one would be opposite. So you really have 3 options. You could go, this one here would be, I'll just do it over here. This would be still 0.5, but now it's negative 0.87. They're both negative. This one, just the x coordinate is negative. Okay. Label the point R on the circle so that angle PQR has a measure, POR has a measure of pi over 2 radians. So half a circle, 180 degrees equals pi radians. If I divide them each by 2, I would say, 90 degrees is pi over 2. So I'm going to put that right up there. And this is point R right there. Okay. All right. I think that's it. So thanks for watching. Hope you enjoyed this video, and we'll see you next time.